going to do some more examples now using different types of forces. So again, this goes to the second document that was listed for you to print off and follow. So now we're going to have many different forces acting on an object. So we want to sketch the actual situation first and then pull out what's called the force diagram, which is just a diagram using the forces that are acting upon the object. So we can look to create a system or of equilibrium, so make three vectors usually kind of work in a triangle and balance each other out. So a 17-meter cable is suspended between 2 points 15 meters apart. So I'm going to have 2 points 15 meters apart. A 10-kilogram sign is attached 8 meters from one end. So the 17-meter is split into 18 meters there and 9 meters there. And there's my 10-kilogram sign. So now what's happening is gravity is going to want to pull this sign down, but there's going to be tension in both sides of the cable that are holding the sign stationary. And we hope that this is a system in equilibrium, meaning that the sign isn't falling to the ground or swinging. And so we want to find the tension in each part of the cable. So 15 meters is not a vector, it is just a distance between 2 points and there's no force there. I have the force of gravity, and then I have the force of tension in this cable and the force of tension in that cable. These three should make a system in equilibrium. So I'm going to start with this one. So I'm going to draw and represent this vector there. Now I have the 8-meter part there. Notice though I'm not putting 9 meters and 8 meters on here. This is a length diagram that represents the situation. What I'm drawing over here is forces. 8 meters has nothing to do with the force or the amount of newtons that is pulling up away from the sign in order to keep it in place. And then gravity I can make as long as I need to fill this in. Now I can figure out the actual size of the gravity force. It's just 10 kilograms. And we talked about this, that it's 9.8 newtons per kilogram. So then it's going to be 10 times 9.8. So the force of gravity is 98 newtons. I want to get the other two forces. It doesn't matter which one is tension 1 and which one is tension 2. I'm going to say this is the first part of the cable, so that's tension 1. This is the second, that's tension 2. Again, the labeling doesn't matter as long as I have them separated. Now the problem is I don't have enough information here to find out T1 and T2. I need some more information about this triangle or some angles. That's when I'm going to come over here and say I have a triangle that I know all three sides. So I can find any angle that I want to. So I'm going to start with that angle right there. And I just picked that for whatever reason. So I'm going to call that capital A because A represents angle. Because I know all three sides, I can't use sine law. I'm going to use cosine law. And you can work this any way that makes sense to you. But cos of A is going to be A squared minus B squared minus C squared over negative 2AB. And it works for whatever one you're, 2BC. That's why I talked it out. Because whatever angle you're looking for, that's going to match the first side. Then it's going to be the other two sides there and the other two sides on the bottom. Because now I can fill in. A is going to be 8 squared. B and C doesn't matter as long as I use one each. So I'm going to put 9 for B and 15 for C. And now the important thing is you realize there are implied brackets here. So when I type this into my calculator, I need to tell it the top either by putting it in brackets or hitting equals. And then I need to put the bottom in brackets as well. So I'm doing 8 squared minus 9 squared minus 15 squared. I hit equals. Divided by bracket, negative 2 times 9 times 15. Close my bracket, and then I'm going to inverse cos because what I have on my calculator represents the cos of A, and I just want angle A. So I'm going to shift cos that. Whoops. And I get 26 degrees. Now I want to think about how that helps me. This is T2. This 15 should be horizontal. So that means whenever I have a horizontal and tension 2, there's a 26-degree angle with them because those are alternate angles or parallel. So here's tension 2. So I have that. So that means that's 26 degrees. My diagram's a little off, but I'm not worried about getting it super accurate. Now, the thing about gravity is gravity always pulls perpendicular to the horizontal. So I know that it's 90 degrees between my 98 newtons and my horizontal. So 90 minus 26 is going to give me 64 degrees. I need some more information, so now I'm going to find this angle up here, and I'm going to call that one, which one? I'm going to call that B, because I put 9 in for B, but I no longer have to use cosine law. Now I have a complete set of information. I know this angle here and that side there, so I'm going to switch to sine law. So sine of B over 9 equals sine of 26 over 8. I'm going to cross multiply by going 9 times sine of 26 divided by 8 equals, I'm going to shift sign that because that's sine of B, and I want the actual angle for B, and I get 30 degrees. So again, this is T1. Anytime T1 meets a horizontal, the angle is going to be 30 degrees. So I'm going to think about a horizontal there. Here's a horizontal, there's tension 1, so that needs to be 30 degrees. Because gravity and horizontal are always perpendicular to each other, that's going to be 60. Well, if that's 60 and that's 64, 180 minus 60 minus 64 gives me 56 degrees. So now I can find, I'm going to use sine law because I have a pair, I have the 98 newtons matched with the 56, and I'm going to put that in the middle. I'm going to say 98 over the sine of 56, because the nice thing about sine law is that you can write it in either order. You can have your lengths or your forces on top and your angles on the bottom, or you can put the angles on top and lengths or forces on the bottom. And T1 is going to go with the sine of 64 because they're across from each other, and T2 is going to go with the sine of 60. And now I'm just going to cross multiply. So then I'm going to get T1 is equal to sine of 64 times 98 divided by sine of 56, sine of 56, sorry. Sine of 64 times 98 divided by sine 56 is 106. And then T2, I'm going to cross multiply again. This time I'm going to do 98 times sine 60 divided by sine of 56. (102). So there's 106 newtons pulling this way and 102 newtons pulling that way. The next example. A large balloon is tethered by 2 guide wires. So there's my balloon. There are my guide wires. And they are 20 meters apart on the ground. The buoyant forces on the balloon, so whatever gas is in here, are pulling it up with a force or a magnitude of 850 newtons. The wires make 58 degrees and 66 degrees angles with the ground. Find the tension in each wire. So again, this is my situation diagram. There's the balloon, it wants to go up. But these wires are pulling it down and have tension in them. I'm going to consolidate them. It doesn't matter which one I call T1, T2, but I'm going to make my diagram. So I have, there's my 850 newton, because the buoyant force is going to want to pull it straight up. My T1 goes down this way, so I'm going to go like that. That's my T1. And then my T2 is going down this way. And these should form a triangle if I'm in a state of equilibrium. They're all balancing each other out because the balloon is hopefully staying still right there. I can't transfer a lot of information or any lengths over to there. I can transfer the 850 because it is actually a force measurement, but I do have information about angles. I know the angle between T1 and the horizontal is 58 degrees. So that's a 58 degree angle there. So if I do 90 minus 58, I'm going to get 32 degrees. The angle between the horizontal and T2 is 66 degrees. So there's my T2. So that's 66 degrees, which makes this 24 degrees. I can do 180, subtract 32, subtract 24, and I get 124. And now I'm really already at this point. I was here, I can go right to sine law because they gave me the angles. And the 20 is really inconsequential. It doesn't impact on my forces at all. So I'm going to put what I know in the middle. 850s over the sine of 124. T1 goes with sine of 24, and T2 goes with sine of 32. I'm just going to cross multiply with my calculator out of there to get my two answers. So 850 times the sine of 24 divided by the sine of 124 gives me 417 newtons. And 850 times the sine of 32 divided by the sine of 124 gives me 543 newtons. And these actually work out to more than the 850 newtons, which makes sense because not all of the energy from here, or the force, is pulling straight down. Some of it is pulling horizontally. So there's a little bit more happening here, and in total we're counteracting an 850 pull of gravity, but some of our energy is being wasted horizontally. Okay, example 3. An 18 kilogram trunk is on a ramp inclined 12 degrees to the horizontal. Find the component of the gravitational force that is perpendicular to the ramp, and find the magnitude of the force pulling the trunk down the ramp. So again, I'm going to start with a situation diagram. So here's my trunk. Gravity always pulls perpendicular to the horizontal, but the trunk isn't going to fall through the ramp. The gravity is going to have an impact that it's going to go down the ramp. So this is the difference. The gravitational force perpendicular to the ramp, because there's another force that is sticking it to the ramp, and find the magnitude of the force pulling the trunk down the ramp. So gravity has an impact of two things. If gravity didn't stick the trunk to the ramp, the box would float off into the air. So because gravity is pulling straight down, two things happen. The trunk sticks to the ramp, which is the perpendicular force, and it slides down the ramp. So now I'm going to take, this is force of gravity, this is the force perpendicular, and this is the force parallel. So I just use a perpendicular symbol and a parallel symbol. You could do PER for perpendicular and PAR, whatever notation you want to do to keep it straight in your head. I can find out the actual force of gravity. This FG is going to be 18 times 9.8, so it is 176.4 newtons. So I'm going to take these and make a triangle out of them. So FG is 176.4 newtons, and it goes straight down. F parallel to the ramp and F perpendicular to the ramp, I didn't quite draw my diagram right, but there should be a 90-degree angle in there. Because parallel to the ramp and perpendicular to the ramp are at a right angle to each other. So now I need to get some more angles happening in there. I'm going to fill this triangle out. If it's 12 degrees there, then I know it's 78 degrees there. And so between the force parallel and gravity, so FG in parallel has a 78-degree angle. So there's my F parallel, there's my FG, so that's going to be 78 degrees. So then that's going to be 12 degrees in there, because 180 minus 90 minus 78 leaves me with 12. I could use sine law or cosine law, but because this is a right angle triangle, I can actually SOHCAHTOA. I'm going to work with the 78-degree angle. It doesn't matter, you could work with the 12-degree angle, but FG is my hypotenuse, F parallel is my adjacent, and F perpendicular is my opposite. So the sine of 78 is my force that's perpendicular over 176.4. So the force perpendicular is going to be 176.4 times the sine of 78, or 172.5 newtons. And my force parallel is going to be cos 78 equals my force parallel over 176.4. And so my force parallel is going to be 36.7 newtons. Now we're going to find the x and the y components of the vectors u and v down here. And again, vectors can be represented by bold or they can have the vector sign over them. Either way, it's the same. So I know the magnitude of u is 11 and the magnitude of v is 8. And I want to find the horizontal and vertical components. Well, whenever you have a vector that's not acting perpendicular or straight up and down or straight across, it has components. This here is the result of some force going over and some force going up. So that's the horizontal component and that's the vertical. Sometimes it's denoted Fx and Fy. So both of them have it happening. So I'm going to look at V first. The vertical force is my opposite. The horizontal force is my adjacent. My hypotenuse is 8. So sine of 32 is force vertical over 8. So that's going to give me force vertical of equal to 8 times the sine of 32, which is 4.2. And then cos of 32 is going to be force horizontal over 8. So the horizontal force is going to be 8 times cos 32, which is 6.8. So now the x and y components are going to be 6.8 and 4.2 on that side. Here they gave me the 47, not a big deal, then I know it's 43 degrees. So I'm just going to repeat the process. Sine of 43 is Fy, or force vertical, over 11. So that's going to give me 11 times sine 43, 7.5. So that's 7.5 is the vertical component. And then the horizontal component is going to be cos of 43 is force horizontal, or force x, over 11, which gives me 8.0, so 8. So that's 8. Last example, a 5 kilogram sign is hanging down, suspended by 2 wires attached to a pole. The wires make 45 and 60 degree angles with the pole. Find the tension in each wire. Very similar to the first 2 questions we did. So I have a pole, there's a wire, there's a wire. One makes a 45 degree angle, the other makes a 60 degree angle. There's my 5 kilogram sign, which has a force of gravity of 49 newtons. I did 5 times 9.8. There's tension 1, there's tension 2. I want to consolidate the forces into a triangle. So gravity works straight down and it's 49 newtons. Tension 2 is going this way. Tension 1 goes that way. The angle between tension 1 and the horizontal is 45, which also makes this a 45 degree angle. The angle between the horizontal and tension 2 is 60 degrees, which makes that a 30 degree angle. So I have 30 and 45, which gives me 75. When I take it away from 180, I get 105 left for that angle. So 49 over the sine of 105 is the same as T1 over sine 30, or T2 over sine 45. And I'm going to let my calculator do my work for me. So 49 times sine 30 divided by sine 105 gives me 25 newtons. And 49 times sine of 45 divided by sine 105 gives me 35.8, so 36 newtons. So the key is to make your triangle transfer over. You can move angles and forces from the situation to the force diagram, but you can never carry lengths. And this first example, I couldn't take the 50 and the 9 or 8, and move them over to the force diagram. I had to work with them to find angles, which I could move. The only thing you can move from one diagram to the other are forces.